section B, B2, complementary angles. So let's look at a situation here. I'm going to draw two axes here, an x-axis and a y. Now, we could label this x-axis and we could label this y-axis. But often people don't put the dash and the axis there. They just leave that out. And the y-axis, it's understood that that's the axis. But the individual y values would be along there. So I'm going to make here a rectangle. That's going to be perpendicular to that y. It's a little rectangle here. So these are right angles everywhere. And we'll draw a nice diagonal like this. So this is a rectangle. All the angles are 90 degrees. And we're going to call this angle alpha and this angle beta. In high school class, we would all often just put, say, one arc and then two arcs for a different angle, but it's not usual the case to put a different number of arcs. You could just put one arc for everything. So here we have the point. We'll label this the point x and y. And alpha plus beta is a 90-degree angle. So we can write that as 90 degrees, or we could do radians, pi over 2. Now the definition of the cosine of the angle, the definition of the cosine of the angle is to take the side here that's along the x. When you have this set up like this, you take the one along the x axis and you divide by the length of the green line. We're going to make that green line equal to length 1. So this is the point xy, means that this distance here is x. And this distance here going up is y. So the definition of the cosine of the angle is to take the x and divide by the 1. So it's simply going to be x. And the sine of the angle is going to be the length of the red one, which is your y, divide by 1. Now, the way you want to remember these, you get the various legs of the triangle correct. What you do is you look at the hypotenuse, that's the longest one, because this is a right triangle. And the adjacent one is the x, and the opposite one is the y. So you want to take, for the cosine of alpha, you want to take the adjacent side, which is x, and divide by the hypotenuse, which is 1 in this case, so it's just x. Then for the sine, you take the opposite side, which is the y, divide by the 1, and you get y. So what I would like to do here is show you a relationship, because these angles are complementary. Complementary means that the two of them added together gets you 90 degrees or pi over 2. That's the definition. And we're looking at the definition of cosine and sine in this review also. So now if we look at the sine of beta, using the rule of opposite or adjacent, for the sine you want the opposite. So you would go here with the beta. The opposite side is the red one here, that's your x. So the sine of beta is x, and the cosine of beta would be the adjacent one. Once when you have your hypotenuse designated, then it's easy to find the opposite one probably first. That's going to be this one. The opposite one's your sine. So the sine of beta is going to be here. This is x, this distance x. And then the adjacent one here is going to be the cosine of beta. It's going to be y. So now you can see a nice relationship that when the angles add up to 90 degrees, that the cosine of alpha here, which is x, is equal to the sine of beta. And that's a neat rule. And then here, if you want the sine of alpha, which is y, that's equal to the cosine of beta. So the sines and cosines are like swaps. So cosine of alpha, sine of beta, sine of alpha, cosine of beta. And that's the relationship with the complementary angles. Now I would like to also express the beta here as pi over 2 minus alpha. So that's what beta is. It's equal to pi over 2 and just take away the alpha. So subtract alpha from both sides of this equation. You get beta is pi over 2 minus alpha. So with that, we can write the formula this way. Cosine of alpha is equal to the sine of pi over 2 minus alpha by just putting in this by substitution for the beta. So that equation becomes this one. And then the sine of alpha is equal to the cosine, putting in for beta the same thing, pi over 2 minus alpha. So these relationships are good to always have in mind in our course. We'd like to add one more review, and that is the tangent. The tangent of an angle, alpha, would be equal to the sine of alpha divided by the cosine of alpha. So the tangent of alpha is equal to, look at this, the rise over the run. The concept of the slope, say the tangent of alpha. If we had the line, this is a line going through the origin, that is the slope. But we'll simply remember the definition as here, take the sine alpha and divide by the cosine of alpha. So if we look at this, the review also of the cotangent of alpha, you flip these around. It's the cosine of alpha over the sine of alpha. All right. So we could write the equation that the tangent of alpha is equal to, in terms of beta, watch this trick, the cosine of alpha is the sine of beta. So this would be the sine of beta, and the sine of alpha is the cosine of beta. The sine of alpha is the cosine of beta. So the cotangent of alpha is equal to the tangent of beta. The neat little rule here is that if you have the cotangent of alpha, it's equal to the tangent of the complement. So I can write the tangent of alpha as the cotangent of beta. It's a nice little relationship there. And then finally, since beta is pi over 2 minus alpha, I can write this as the cotangent of pi over 2 minus alpha. So these two relationships here, we're going to add a third one to it, that the tangent of alpha is equal to the cotangent of pi over 2 minus alpha. So these three here.